Hello. Hey, look, there's sound. That's awesome. Actually, can you join? Yeah. And make sure that we're seeing this. And it's looking pretty empty right now, so we're going to give it a couple more minutes before we actually get started. Oh, I should do one other thing. I should screen share. Make sure that works okay. Share. Yay. Send to everyone. Okay. And then I pasted it in the meetup. Okay, so I want to go to Azure Books. Actually, I need that. I was like habit. Okay, here we go. Azure needs. We do have a dog. Okay, this one. Okay. Alphabet science. And can you hear me? Yeah? Yeah. Excellent. Yeah, that's pretty normal. All right, excellent. So everything's set up. We're waiting for some folks to arrive. So we'll start at 6:05. Maybe. Destroy this thing. It's dead. It's dead, Jim. Hopefully I didn't get very much. That's just cheese and pepperoni. That one's the worst. Unless pepperoni. Okay, sorry. This is veggie. That's the worst. Oh, that was the pepperoni. That's good. Okay. Yeah, what do we have on the remote? Well, this is going to be fun. This is going to be fun. Yeah, that's what I was worried about. That's why I switched off of that. Is there someone? I'm hearing audio from us. From us? Oh. That's why I switched off of that. Someone? Oh. There we go. Cool. Plus one crazy dog. That's you. FYI. If Chantal were here, she would say, is one of us supposed to be a dog in this scenario? Yeah.
I'm the dog.
Hi.
I'm the dog. Hey, how you doing?
Pretty good. Small group tonight. Sorry,
I'm
that's
Russ again. I was
Scott.
Scott. That's right. Oops.
That's
Exciting. Your book looks pretty clean, though.
the what?
The book looks pretty clean.
Oh, you mean not a lot of bookmarks and whatever? Yeah.
Yeah.
Well, I do everything in Jupyter, so I don't have to worry about it. All my notes are external. Oh, drinks. Right. What? No, not so much comparing. Yeah, other stuff. Okay. No, 1 minute. Here, tell you what.
No, don't go over there.
I'll just bother everybody the whole time. Don't even think about it. That's it. Once you play with them, it's over. Now, Grim or Grimmy.
Are you just so excited?
Yeah.
Are you going to learn some art today too?
Yeah. This is actually Ike's dog.
Really?
Yeah, he left this morning, and Grim is now in my care.
You're going to have a fun time today, huh?
Okay. So, I think let's begin. We have a quorum, and we have a couple online.
What was our chapter?
Our chapters were through 18, so 12 through 18. Originally, when we divvied up the book, we divvied to 18, but not through 18. But Ike, I guess, made a spur of the moment, a command decision last time to basically go through chapter 18 just to start getting into some of the more interesting stuff in R. So I have not read chapter 18. So this should be fun. But I'll try my best to get through it. And then the next time we basically have part 4 of the book, which is the last part of the book. So the next reading assignment is all the way through, basically.
So I have read the whole book,
Excellent.
and this is tough reading right here.
Yeah, yes, it is. It absolutely is tough reading.
But I've learned something important on R.
Yeah?
So R is really something for statisticians to visualize. It was described to me as a statistician's calculator. And statisticians don't really generate the models. They throw it over the fence to the programmers. So really what we're learning here is the visualizations of how to visualize the data. And then probably Python's a better way to create your models.
It could be. It could be. So I think of it like this. R is a very good language for data exploration.
Yes.
It's much easier to explore data in R than it is in Python. If the data exploration is going to be consumed by a very small number of people, it's not going to have a huge amount of maintenance. It's not going to be like scaled to hundreds of thousands of users and stuff like that, then R is the right tool for the job from beginning to end. But you're right, if you've got a serious project that's going to be consumed by lots of people and has a lot of people, it's going to have a lot of maintenance over its lifespan, then Python, I think, just due to the fact that in R, everything's pretty much a global. And in Python, you have these more, you can put things in classes, you can put things in, libraries, and, you have this more layers of encapsulation that are available to you.
Right.
Just due to that, it can make some of the long-term maintenance of the models easier. Yeah. So I with some qualifications, kind of agree with your assessment. Yeah. I mean, in some cases, I think R is the right tool for the job all the way through. But that's just me. So we got started with chapter 12, which is factors, which in other languages are called enumerated values. The library for dealing with those things in R is, I found the name kind of unfortunate because I kept wanting to say library factors. And it was library for cats. And it's I don't know, some sort of weird, play on words or something. I'm not sure. Anyway, so let's see. I mean, for me as a programmer that had a lot of background experience in other languages, a lot of this stuff felt similar and kind of intuitive and easy to understand. There's very little that I felt was surprising. So I wrote a little bit of background material in my notebook here, and then I just went straight on to the exercises. So the exercises here in this chapter were, I don't know, they felt a little repetitive compared to what we'd done earlier with the flights and some of the other stuff. But I guess let's start with page 227, which was the first set of exercises in the chapter. 227. And here it's just asking, explore the distribution of the data set that we were dealing with, which is this GSS cat thing, which was the it was social, what was it called again? Yeah, General Social Survey. And explore the data, the distribution of our income, the reported income. and what makes the default bar chart hard to understand, and how could you improve upon it. And if you do the default bar chart, the labels are on the bottom and are all squished together because the labels are so large. And so the main thing that you can do to improve it is to do a chord flip so that you get the X on the Y-axis and the Y on the X-axis. And then the only other thing that I felt like was kind of confusing about the chart were all of the not applicable, refused, don't knows, and no answers, and they're in different orders. And so it was hard to see, like, is it getting bigger or is it getting smaller? But if you took all those out, then it became pretty clear that it is a exponential growth upward.
There's a way to move them, right?
Mm-hmm. Mm-hmm. Hi, Ted, right?
Yes.
Yep, Scott. So if, yeah, you can move them, and there is, let's see. I think that's covered in the next set of exercises, if I remember correctly. Yeah. So question 2 was the most common religion in the survey, and that was pretty simple. A count would have given you that, and Protestants the clear winner by double its next highest amount. And then it asked to count the parties, and independent was the winner there. And then it asks, which religion does the denomination, the denom column, apply to? And how can you find out with a table? And to find out with the table, I said, take the amount, filter the denominations that are no answer, other, don't know, not applicable, or no denomination, and then basically count the religions that you end up with, and they are all Protestant. So that was an easy, clear answer. The graphical answer was a little bit more fun to look at, which if you use that, I had to look it up again because I no longer remembered chapter 3, but you can use that stacked bar chart. And if you do that, the geom bar with the fill, it basically shows you that within Protestant you have all kinds of denominations, but other than a little bit of other and a little bit of Christian that both said no denomination, then yeah, anyway, they were all single color. So that was 227. And then you were talking about modifying factor order. That's that next little section. And first we talk about suspiciously high numbers in TV hours is mean a good summary. I had said no, median is probably better if they're outliers. That's just a well-known statistical fact. And then for each factor, identify whether the order of the levels is arbitrary or principled. So this one could have some debate. But the ones that have levels are the marital status, the race, the income, the party ID, the religion, and the denomination. And I've, in my mind, said income and party ID are the only ones that have like an inherent order. Income because they're grouped, under 1,000, they're in the range and they have a clear, they're going up. Yeah, they're numeric, exactly. Party ID is a little bit more arguable, but it was ordered from like left to right or right to left. I can't remember exactly which one now, but I felt like it was, it went like very strong Democrat, somewhat independent, went to then independent, and then somewhat Republican leaning, and then Republicans. I felt like it kind of had an order, even though you could argue the other way, I guess. But I felt like all the others were not. I mean, certainly we're looking at the religions here. They don't have an order. The, denominations of the Protestant denominations, did not have an order either. So that was my thought. Yeah. All right. So this next question, I have no idea. It was, why did moving not applicable to the front of the levels move it to the bottom of the plot? And I plotted it both ways. And sure enough, it did move it to the bottom of the plot. But I don't really know why.
That was facet level.
RDN, nope. Nope. Yeah, facet relevel, exactly. But in the book, he says that it goes to the beginning. And I thought I looked the help up for that. Ah.
There's a default after 0.
Oh, okay.
You could say what you wanted after, but you don't.
Gotcha. Okay, that makes sense. So basically, the default level, if you don't assign one, is 0. And so you'd have to basically say not applicable is -1 or something like that to get it to go up to the top.
Did you just read that somewhere?
Oh, I did question mark
Facet.
underscore relevel.
Yeah. Here, we can bring that up here. Let me expand a little bit. So I can do I'll enter. I can do question facet relevel. And then,
Actually, int is releveled to the.
Wait.
Oh, 0 is the beginning.
Facet relevel.
Yeah. 0 must be.
Yeah, because they're 1, 2, 3, 4.
Yeah. So after 0 means it'll put it in position. So that's how you get it first. And if you want it at the end, you would say after.
Where did you get facet Oh, is it because I haven't loaded these? If I said rerun everything, is that why? Hold on.
Or you can just run the one.
Well, yeah.
Do you have forecast?
Yeah, probably I need to run this one. And then run that one, which was here. There we go. Okay.
Yeah, so it's described.
Yeah.
After the third position, you put it after 2. Level to the end, set after infinity, unless you know the length.
Okay, but so after equals 0 is the default.
So 0 is the very beginning.
Yep.
So it would move it to the 1, which is what it.
But it's putting it at the end.
Isn't it? Oh, no, isn't it doing from? Doesn't it do the factors from the bottom up? When you did you plot it?
Yeah. So here was the plot without releveling. And then here is the plot after releveling, where it took not applicable.
So I thought that the bottom position on Y was the first element. No? Can we see? We can see that, right? We can.
Oh, I guess that makes sense. Okay, no. That does make sense, actually.
You can show levels.
Yes, it's because the difference in Cartesian, it's basically like Y is going up. Yeah, 0, 0, 1, 1, 1. Okay, I got it. That makes sense.
There is a way to see.
Yeah. Okay, I get that. That's clear. Right. So Cartesian.
See the order of,
I think levels, but otherwise you can use.
yeah, I did that, but then it just gave me numerics for or it dot 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 is like what were we looking at? Ringcom?
Yeah.
Factor with 16 levels. No answer, don't know, dot dot. But you're saying if I type levels.
So if, yeah.
Levels
Well, you'd have to do. Yeah, no, it should be levels of.
it might be right.
Well, if you specify the data, it's $1.
Oh, I'm sorry, I did the wrong button. Let's try that again.
Oh, that's interesting. Dollar.
Well, I'm saying it's not inside of a tiny like you just do level. It doesn't know what data.
So I did.
Well, Ringcom is
dollar ringcom type to level.
Okay. And
that gave me no answer. Don't know. But actually, yeah, as the factors increase, they go down.
Yeah, so
Less
that's
than
what was
1,000.
unintuitive.
Yeah.
Is that the
Yeah.
lowered number
Later
levels are the higher dollar amounts.
Yeah.
The levels are actually in reverse order.
Right.
So that's interesting. So GG plots from the bottom up.
well, yeah, it's Artesian, you know, 0, 1, 2, 3. Yeah.
You put it that way. It
Yeah.
makes sense, but-
Yeah. I think that's the answer he was looking for. Because GG plot y-axis is.
Now you did create the level. I would have the lower number.
Yeah, that would make more sense to me.
And then the graph would have been upside down, but then it would have been very obvious
Yeah.
what was the top and what was the bottom.
Yeah, I agree. Okay, that was a good little discussion. Okay. Let me kill that. Okay. So then we had 235. Where in this section, we're talking about this is actually like mutating them. Yeah, changing their values, right? So before we were just reordering them. Now we're like crunching them together or splitting them apart or something like that. So, and it's that facet, recode, or facet collapse that we're using, or facet lump. Yeah, it is factor, but I like facet actually, the facet of the factor. Which facet of the factor are you going to collapse? So I like that pronunciation actually. That's a nice facet collapse. You know, you're collapsing a facet of the factor. Anyway, so the proportions of people, how have they changed over time? Democratic, Republican, or independent? What he's wanting us to do there is basically there are a number of Republicans and there are a number of independents and there are a number of Democrats. And so if we just smush them all together, then we get something that, you know, you can see that. Can you see? No, you can't. Does anybody know how to expand a single cell in a...
You click the little
colored what?
colored bar on the left. And class.
Yes. Okay. There we go. Cool. And so you can see that always there are more independents than Republicans or Democrats. Certainly in some years, there's more people that vote. That was 2006. You know, but
If you did one of those stack barring things, it would always add up to 100.
yeah, then we could level if
Relatively.
yeah, that's true. That's true.
How did the percentage-
but it's still, well, I guess it doesn't have the latest data on there is the problem. Hold on just one second. Hello? Okay.
The main thing was just combining.
Yeah. Exactly. Yep. Indeed. Okay. And then how could you collapse the income, the reported income, into a small number of categories? And so they were almost broken down by 5,000 chunks anyway, except for the ones at the bottom. So I just smushed those ones at the bottom. And then I combined the others into unknown. And that, that gave me a nice, pretty even here until it gets up to, 25,000 or more. Which, yeah, I wish we'd kept going to see. I mean, I was kind of interested in the data, but it didn't really give us enough to go on. All right, and that was the end of factors. Questions about factors? No. Okay, moving on. Lubridate. It's kind of an unfortunate package name. There's a lot of unfortunate package names, I think, in R. So it talks about some of the issues, with dates, which, I think anybody who's been a programmer for any amount of time. What is it? John Skeet says, there's only 3 hard things in computer science: numbers, strings, and dates, which is pretty much everything that you deal with. So, but it is funny that those 3 things, like floating point comparison and that sort of stuff is really difficult. And then, strings, I mean, not so much anymore, but it used to be especially difficult when we were dealing with all these different, like some strings were terminated with a specific character, and some strings, the length was prefixed with the actual string, Oh my gosh. And then there's UTF-8 and Unicode and character sets and then dates, of course, politically, there's half, 30-minute time zones. There's, time zones that are changing, even like, I think I saw something recently, like there's some sort of time zone change proposal going through Congress right now. Yeah. So, yeah.
Well, they've changed the start and end dates for daylight saving several times.
Yeah. They've changed it over time.
So even if you know exactly when daylight saving starts, go X many decades back, it's not accurate anymore.
They mentioned in here, I think it was later on in this chapter, but they were talking about Detroit, who pulled themselves out of daylight savings time for a couple of years and then put themselves back into it. So dealing with those dates is going to be super fun. But basically, this is like the moment, in JavaScript of for R.
I was surprised to learn that not every minute is. Did not know that.
Yeah, leap
once
minutes.
Every, yeah, I don't know how often they do it.
Yeah. Yeah, it's not every year though, right? It's not every leap year.
Like
not every leap year.
30, 50 years.
Yeah, something like that. They added an extra leap second in there. Yeah.
It's not.
Yeah.
Good reminder of how arbitrary.
Yeah. And he does say, the reason for it is because you're trying to model, physical phenomenon that don't line up to our.
Why don't we just base everything off of? Why don't we say, oh, I'll meet you at sunrise?
Well, it is, but it is. I mean, like a day and a year, those are the physical phenomenon, right?
They're abstractions, approximations of the physical phenomenon. The actual physical phenomenon is like, where is the sun in the sky?
But if you did that, then every house would be in a different time zone. So.
Yeah. That's true.
It actually did used to be that way. Like in the West, every town, noon was, yeah, that's how they set their clocks, right? So,
That's funny.
but so like, I mean, I didn't do the exercise this chapter. I was just, wow, I'm really glad somebody took the time, do all this work, figure all this stuff out, that I could just call this function and not have to think about it. Like, and then at the very end of the chapter, I can't remember what it is, but when he talks about like, if you just want like a human intuitive thing, so like one day from this time, and I was thinking to myself, well, I don't know, like if like you happen to pick the day before daylight savings kicks in, right? It's like a day from 2 p.m. Do I want 2 p.m. tomorrow or do I want 1 p.m.
That's why this stuff is so hard and so arbitrary. Yeah.
So I guess if you really wanted 1 p.m., then you should say 24 hours from now.
Yeah.
And if you want 2 p.m. tomorrow, no matter.
Yeah. A day, period.
Yeah.
Then you use that one.
other function
Yeah,
that
yeah.
will just figure out if anything weird happens, like a leap second, a leap hour, a leap whatever. And
Yeah, so there were some exercises that were 243, which I felt were just, I don't know, brain dead, easy. I didn't really get a lot out of them. But on 248, we started getting into the more interesting exercises that here, even right away in this one, how does the distribution of flight times within a day change over the course of the year? And when you plot this, you notice that miraculously, the months with 31, are higher on the graph because they have more days. There's more flights, right? So already you're seeing, and here I could do that same thing. I could do the like normalized density or whatever it's called, like to basically get those so that they're all the same. But you can see the February one is this guy, this one at the bottom, right? And if you were to normalize that, they'd all be really close. In fact, when you do that, there's really not a lot of difference that you can see. So I'm not sure what he was going for. I don't know if anybody did the exercise and found something different than I did, but
it was flight times within a day.
yeah. How does the flight time within a day? So this is the one where you have to take the hour and multiply it by 100 and add the minute to basically get 24 or 2359. Would be the 0 to 2359, 2359. Yeah.
I don't know if he was going for that during daylight savings. Times shift a little bit.
Interesting. I didn't even catch that one. Yeah. Yeah. And then the next two, I feel vindicated because in chapter 3, I was complaining about these very values, these departure time, scheduled departure time, and departure delay. And I was like, these numbers just flat out do not add up any way you slice them. Are they consistent? Explain your findings. And I said, I already know they are not consistent because I scrutinized the heck out of them, chapter 3, trying to make them line up, and they just don't.
So there's no explanation for it?
No, it's just like human data entry error, I think, or something. I mean, they're not scrubbed. I mean,
Right.
In no way does the flight duration, the scheduled departure time plus the scheduled delay or whatever equal the actual departure time, and the other way around,
Right.
at the end. So this is horrible. And then it says compare airtime with the duration between departure and arrival. Explain your findings. So I did that, and once again, it's like just off in all sorts of ways that are not consistent. And so I said, basically, my findings are crappy. It doesn't matter where, and so there are some interesting ones here. These ones that are like way wrong. And those we do explain later on, I think, in this chapter, right? So those ones are the ones where the departure time, it was a overnight, basically. It crossed the day boundary. And so when you subtract the the arrival time minus the departure time, you get some crazy negative amount. Yeah, exactly. So that one was pretty interesting. And then how does the average delay time change over the course of the day? And it says, should you use departure time or scheduled departure time, and why? I need to put him up. Is he gonna go ballistic? No, I don't want to do that. I just put him in the office or something. Okay. And when I started doing this one, I was like, well, my instinct says use scheduled departure time, but I don't know why my instinct says that. I couldn't figure out what sort of process, how did I choose scheduled departure time? I didn't know, so I plotted them both. And here was scheduled departure hour, and then here was just departure hour using the just the departure time. And you can see that the data is all screwed up because of those flights from the previous day or whatever. So it is right, the scheduled departure time. Yeah, previous night delays skew the data otherwise. So what happened here? I don't know. I was messing around with this one. Crap. I don't remember what I did. What day of the week should you leave if you want to minimize the chance of delay? I feel like the answer was Sunday, but now I was trying to get a better plot and I never got it. So day of the week is group by day of the week. I feel like I might need to as factor this thing or something. Yeah, I was trying to break it out into. I was trying to show the densities, but it didn't work. So I think we just go.
I don't remember what's the G on density.
Density are the ones that try and it's the normalize and the stacking. They
box plot kind of?
No. Here, we'll just do it.
Hexagons and stuff like that.
Let's see. Oops, that's Jimbo. How do I do it? Oh, it's spelled wrong. Okay, there we go. No, that's at least it's nice and large and easy to read. And zoomable. Hold on. Let me just do it one more time. There we go. So this is like a density of the what am I trying to do here? Grouping day of the week. So I have all of these various points for each day of the week. And I'm trying to basically show a smooth density transition or plot for each of those days of the weeks.
If you're trying to do that, then the x needs to be the length of the leg. Because a density is like a single variable plot. So what you're doing there, you could do a box plot with x being the days a week. And then on the vertical axis, it would show the box plot of the summary of it.
So if I said, plus GM box plot, just boom boom, or
you
I
have to
say
say y. Yes, y.
this was still which delay am I calculating here? Yeah, let's just do X. Yeah. So I think I need to factor that
Okay, you need laughing as.
on that. Oh,
Although both might work.
yeah, I think that's factorable. Okay. I was using before, but okay, it's thinking really hard, so that's a good sign.
Do you remember early on you mentioned in the GD plot? You mentioned that there's a cheat sheet on the RStudio. Like, I downloaded that PDF.
Yeah, I have it. I have it.
And,
Well, I thought I had it. Hold on. It's
but,
probably like sitting on my desk.
yeah, I actually have it open on my computer. But so like, it very clearly says like, oh, here are things that you can draw if you have only one variable.
Yes,
You can draw if you have one discrete and one continuous variable, two continuous variables. Like, okay, so clearly, if I have a different kind of data and I'm trying to use that thing, it's never going to work.
Right.
I don't know what happened here.
Something wrong. So I kept doing that, where it would just be weird. Couldn't understand.
So I have a discrete X and a continuous Y. So I could use geom call, geom box plot, geom data plot, and geom violin. Except for some reason, this isn't working as well as I had hoped. I'm not sure what's going on. It seems to be just hung.
Can you try running it again?
Yeah, but it's running currently.
I've noticed some weird stuff with GG plot where I was reading some stuff about like it
It's fun.
it needs to know what your output device is, and sometimes it gets confused.
Interesting. Where is my scheduled departure? There. Okay, so if I run just this one, come on, and then this one, okay, and then I should be able to go down and run the one we just created.
Hopefully it won't.
And hopefully it will crash. Yeah. Not looking good.
Huh.
I wonder if that as factor, if we need to basically make that.
Well, you could like say you can factor instead of
Yes. See, it says dead kernel up there now. Yeah. Can I- with the candlestick in the billiards room.
But do you see why I'm saying that if you want to do that? what's the
Density.
geometry?
Yeah.
Then you would put length of delay on the x-axis, and then you can do a I don't know exactly, like a group by or something in the AES in order to get multiple density curves, one for each day of the week.
Yeah.
Maybe like group equals.
Yeah. So I'm wondering if it's here to get this one. I wonder if we need to, can I as factor here?
Does it have
Oh
to
yeah,
be
just
factor?
slap a factor around the W base.
Factor of WJ. And then I don't need this.
I don't know why the construction.
Unexpected end of input. Factor, boom, 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 boom. Oh. I don't know that it was ever live though. Let me try this.
You don't need a group by. I think that's
Okay.
why.
Hold on. We go in there.
Oh. Because you've added day of week as a to the
Group by
data
like
frame.
Yeah, X. Yeah. That was when I was trying to do the density thing. I was grouping by. Anyway,
So
so,
what
well, I think I might need to do like
group by might only work with specific flyer functions, like summarize.
no. We have the tidyverse, so we have all of the or anything fed in. It'll take anything piped into it, right? Any data set, data. What is it called? Yeah, data set,
Data frame.
data frame.
Right.
Yeah.
No, I just don't know what functions understand a group by. I know like summarize will, but I don't know if ggplot will actually understand.
Well, here's one, right? So, I want to. Oh, you're saying it goes to summarize before it goes to ggplot.
Yes.
And so if I had
the level.
got it. So if I had. Oh boy.
Hear me?
Hello. Oh, no, come on.
Hello.
Grimmy. All right. So, yeah, I see what you're saying. So if I had used summarize in between group by and my plotting function, that would have been fine. Yeah. Grimmy, come on. Nope, I don't want to go in there. Oh, you got it. You can watch us. How's that? Okay. So, small dog interruption there. We had restarted the kernel. Now I have to do this again. Okay. And then here. Okay. And then if I go down, now that we have there. Yeah, that's I think 4. It's not too bad. Mutate. We did a factor. We did the AS. I'm wondering if it's the mutate that's actually killing it here. This is question number 5 on our exercises on page 248. And we are trying to, on what day of the week should you leave if you want to minimize the chance of delay? There we go.
Okay, it actually worked. I don't like it.
Okay.
Then I think there's some box plot option to do some tails.
Yeah. We could actually do like some violining, right? That's one of the options that we said we could do.
Yeah, we're
Which-
still gonna have tails.
Yeah, which would at least tell us, where the density is.
Either you can add a limit the y coordinates, like an interesting range.
Yeah, but don't we want to just make, like it's hard for us to tell. There's obviously a lot of points going on here. Can't we just say like make the size proportionate to the number of dots? And this is probably why it was taking so long. It's just because I have a feeling there's probably 50 trillion dots in here, and we didn't use any, sort of
Binning.
yeah, anything like that. So
then maybe your density was a better way to go. But then you just need x to be
something else.
x to be
Sorry.
departure delay, and then group equals
Say it again. X
equals departure delay. Group
Oh.
equals day of week,
Okay.
and then change it to the
Let me
Still don't want the group by it.
Yeah, we'll comment that out. Have G plot of AES x equals
The delay, right? That's what on the x-axis. So from 0 to
and then we want to, you're saying group equals a and send that to box plot again.
no, you're on density.
Oh,
That's the way. One continuous.
I'm not sure what I'm looking at here. Archer delay.
Well, most of them are 0, but I don't see multiple lines for the day of week,
Yeah.
or they're overlapping.
Well, I'm not. This. Yeah, I agree. I'm not seeing the days of the week here.
Are they just overlapping, or are they not?
Can we? It looks like it's going from 0 to 1. Yeah, I don't know. I don't know that we want to spend that much more time on it. We got other stuff to cover, but it is an interesting problem. Try and visualize it.
Yeah, I mean, I guess you could just look for what percentage are.
Yeah, I mean, I sent it to summarize in the beginning, and it was pretty discernible that it was Sunday was the best day. But in trying to visualize it, that's why I ran into some issues. So question 6, what makes the distribution of diamond? That's weird. Hold on 1 second. Let me edit this. It's weird. Why would this $sign in italics? Oh, LaTeX. Expression, I see.
How
But
do you escape?
how do you escape it? Put 2 of them?
Backslash?
Oh, that bullet will be, even more fun.
Try one of each.
Yeah. So
That means that you want your formula to be displayed.
that's interesting. Both of those now are, what the heck? So both of those were literal. Yeah. Doesn't matter. This is not the purpose of this talk. Okay, so diamonds, carrot, and flights scheduled departure time. So I plotted these with a histogram, and I think the answer that he's looking for here is humans. What makes them similar? Humans make them similar. If you look at the carrot densities, it's like, 1/2, 1/3. They line up at numbers which make sense to humans. And if you look at the scheduled departure time, it's like every 5 minutes. There's a whole crap ton of them. But in between the 5 minutes, there's not.
I'm saying there's a 5-minute delay, a 10-minute delay, but there's no 6-minute delay.
No, this is the departure time itself, like the scheduled departure time. So this plane is scheduled to take off at 6:35. It's not scheduled to take off at 6:36. 6:35.
Periodic to take into account there will be some delays. So there is some holes in the schedule in which they can squeeze.
No, but technically that time between flights could be, 3.37 minutes or whatever. But the humans line them up on 5-minute intervals just because we're humans. Yeah. 6:35. I mean, like if you look, even the 30, there's a ton of times there. The flight is scheduled to take off at 6:30. Or look at the 0. There's 60,000 flights that are scheduled to take off at the o'clock hour, right? About half as many at the 30 hour, and then hugely disproportional amounts at every 5 minutes. And in between those 5 minutes, practically nothing.
Yes, but they should schedule, time for flights to go out if there was a delay. Because it takes time for a plane to get it to that out. The line very takes off.
Yeah, I hear what you're saying, but I doubt very seriously that time lines up on 5-minute intervals. Because I would imagine that it would line up on 6.1749 intervals. Because the exact time between delays of planes lining up at 5 minutes exactly, doesn't that strike you as really weird?
No, it strikes me as convenient. If every airport does it, they can do, more or less the balance, but schedule it. They would know how it happens. Not the airport would know when the delayed flight would go.
Maybe.
I
Maybe.
think if you, I think if you look at the amount of time between consecutive flights at the same gate, you will find something that has to do with limitations of the ability to get a plane in there, load it up, get them out, blah, 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 blah. Southwest is famous for being able to do that faster.
Yeah. They can do it.
Airline.
They can do it in like 25 minutes, and most airlines are like 40 minutes.
Right. But that interval aside, whether or not the flight is scheduled to leave at 6:35 or 6:36 or 6:37, why it always seems to be a multiple of 5. I think Scott's got a point. It's just because people like round numbers.
Yeah. I don't think the scheduling of times, I just don't think that has anything to do with that, especially because there's always a queue anyway, right? Like, even if it was every 6 minutes or every 8 minutes or whatever it is,
Or look at the very first flight in the morning. The very first flight has no constraints pretty much other than when the airport opens.
Yeah.
And it's never at 6:12.
Yeah.
It's always that.
Yeah.
That's round number.
Yeah, exactly. So I think that's what he was going for in the what's the same is, I mean, like here exactly at a third, exactly at a half, exactly at 2/3. These are just human numbers that, we like, and
Well,
therefore.
And for diamonds, there's actually another factor in that they cut them. So they have control. They get to choose what size diamond they're aiming for when they cut it.
Yeah.
It's not like you dug them up and like, oh look, they all happen to be like,
No, that's what I'm saying. That's my point, is that they are choosing to cut them at precise sizes,
Because nobody would buy a carat with 0.9. If they, have a big rock, they should cut it in a way that it should be not less than 1 carat.
Yeah. I mean, this is actually over. This data is what am I saying? Multiplying by 100. So, I'm not using the right words. It's not like 1.3. It would be 33, right? Would be the number that would have the highest value here, right? You see what I'm saying? Yeah. So it's just showing that regardless of whether it's 2.3 or 3.3 or 1.3, 0.3 has a higher amount than other values. Yeah. Okay. Okay, so this one is, I didn't understand this one actually. This one I had to look up. So his hypothesis is that early departures of flights in minutes 20 to 30 and 50 to 60 are caused by scheduled flights that leave early.
I don't think he said that quite right. I didn't do this exercise, but I think what he's saying is, you look at all flights that leave in minutes 20 to 30, that actually they're not flights that were supposed to leave between 20 and 30. They're flights that were supposed to leave at that big 30 that you pointed out.
Yeah.
That left early.
Yeah.
Same thing.
Yeah. Well, definitely. Yeah.
Basically, he's saying what fraction of all flights that left between 20 and 30 were early versus on time, and it.
Yeah.
Hypothesis. Early.
Yeah. A lot of them are early. Yeah. 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 Exactly. Yeah. So I guess it did show that, but I didn't. This is not my answer. I did not. This one I had to look up. Say that again. So early is if the departure delay is less than 0. And then we're summarizing and we're plotting the percentage that were early. Yeah, or is it percentage? What is it? What are we looking at here? Minute Y early 0.475 to 5.75. Not actually sure. Are we looking at?
Well, this is
group by minute.
The minutes in chunks of 10. It's not looking at 20 to 30.
Yes. Yeah. Oh, 20 to 30. Right.
So it isn't pulling out. Just looking at everything mod 10.
Yeah. Everything mod 10. Hold on one second. So mod 10, the minute, mod 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Right. That's
Okay.
not what you really want. You want to know.
Yeah.
I think we get it.
Yeah. So it appears that this answer that I found didn't even answer the question. Flight was delayed. Yeah. Okay, and so then we started talking about time spans, and now we're getting into some of the things that you were bringing up in the beginning, Ted, about the fact that there is a periods, which represent the human units, and durations, which represent sort of more atomic units. And we need both when dealing with times, because sometimes you want a day to be 24 hours, and sometimes you want it to just mean the day, regardless of whether it was leaped or not. So the first question gets to that. Why is, on page 253, why are there months but no D months? Well, it's because months doesn't have an atomic duration. Yeah, it doesn't have an exact duration. Well, D months would be would have to be in seconds. Yeah, would have to be some sort of atomic, it doesn't matter which unit you choose, seconds, minutes, hours, days, even. Months aren't, there is no fixed, value that you can use for a month.
It would depend on what your starting point is.
Yeah. Yeah. So there's no, there's no consistent, there's no consistent value there.
Although there is
Yes, but that could be 365.25, right?
I think he said there's like a warning.
Yeah.
Only approximately, not all year.
But you're pretty close.
Right.
Yeah.
Whereas months.
Once you're always off.
Yeah. By the way, I actually used this Uber date thing because I had a script that was running for a long time. And I grabbed this time at the beginning, at the end, printed how long it ran. And so at first, when it was running faster, it was like, 30 seconds, 45 or whatever. And once it got to 65 seconds, then it said 1.02 or whatever.
Yeah.
Now recording in minutes, but when I convert the duration to a string, it only converts the number. It doesn't show the unit.
Oh, that's unfortunate.
Yes. So then rather than doing the work of grabbing the units, I was like, oh, okay, I'm going to use this duration thing. And then it said 65 seconds approximately. That's really nice.
And it's funny because I used it too for something, but nothing in this chapter applied. But it was a much easier way that I was trying to parse some dates out.
Yeah, I mean, in R, I don't do a lot of work in R, but in other, like JavaScript, for example, I mean, almost every single project that I write pulls in moment at some point. Like, you just have to know, I want to take, I want to translate time zones, like I'm getting dates off the server and they're coming back in UTC and I want to display it to the user, not in UTC. Or I want to do some sort of summarizing over days or over weeks or over months or over years or whatever. And it's just really, really difficult without some sort of date library. I mean, he talked about in the time zone, I think that'll be next actually, so maybe we're jumping ahead, but he talked about in the time zone section how, there is a database which keeps track of all the information of the time zones, and every time there's a law that's passed or whatever, they have to add another entry into that database, and it's grown large over time as humans try and screw with dates.
Yeah, I mean, thankfully somebody else is keeping track of that.
Yeah, so that reinvent the wheel, if I had to do time zone calculation by hand in every single project, that would add like weeks, that would suck.
It was weird because last week I was in Florida, and so I set my watch for Eastern time. The section of Florida I was in was still Central time because it doesn't.
Oh, the panhandle. Down. You're in the panhandle.
It's left and then down. So the good thing I was an hour early for everything
instead of an hour late.
Yeah. So second question here was explain days overnight. Someone who just started learning R, he's talking about this particular thing. days overnight times 1. So, yeah, I mean,
Yeah, it's like 24, 25 hours or something. I saw that.
yeah, yes,
Adding a
I think
day
that's
to the
correct. Actually,
25
yeah,
hours.
days is the period. It's a period, right? Because if it were duration, it'd have a D on it. So that is the human day. That is correct. And then the human day of the $sign, I'm sorry, the multiplication sign, the asterisk 1, would coerce that Boolean value to a 0 or a 1. And so you're basically adding 0 or 1 days, human days, to the time. Yeah. So it's a clever little trick. It's this stuff reminds me a lot of JavaScript because there are those same clever little tricks in JavaScript. Okay. What did I write here? Sorry. Oh, that's just the outcome. Apparently, I didn't do the last part. Okay, so creating a vector of day. Oh, I remember. I felt like this part was kind of trivial, so I was like, whatever, basically. But this is an interesting thing. This is another one that I didn't figure out because it appears to work for me. So question 5. It says, why can't today, and then this operator, this minus operator, which I think is just the minus operator. But maybe it works over dates, whereas normally it requires some numeric thing. I'm not sure. And then today plus years 1 divided by months 1. Why does that not work? He was asking. Yeah. But
I think
yeah.
Isn't that thing what we were talking about at the beginning about there's no D month because months vary?
Right, but here he's not using D months, he's using months 1, and today plus years 1 divided by months 1, that's 12, which is what I would expect.
I think this won't work on certain days.
Yeah, I think he just worded it incorrectly then because he's asked why can't it work? When would it not work is what you're thinking maybe he's asking. Okay.
What is month 1?
Months would be a non-duration, so it would be a period. So that would just be the period of 1 month.
Oh, so that's February 1, 1900 or whatever?
No.
Or it's a duration.
Yeah.
I mean
a period.
So it's just 1 month. Oh,
yeah.
It's not a particular.
Yeah.
A month.
A human month. Right? So it's basically saying a human year divided by a human month is what? But it's saying today, I don't know why he's using that.
Operator is?
I mean, you can add and subtract a year or a month, but I don't know what it means to divide by a month.
Well, hold on. Let's find out what this is. That's our first step. How do I do that for operators?
Oh, you just type it in the help box. I'm not sure if you can actually find it because
I'm going to try a Google search.
yeah.
Oh, creates an interval that covers the range spanned by 2 dates.
Okay. So it's basically like a a subtraction.
Right. So it is like
Yeah. So it's like beginning, the beginning and then the end, and it takes the difference of those two things.
So the interval between today
And today plus 1 year
year
from today, and then divided by months of 1. I don't. I just don't get it. I don't
Is it
know.
because one's an interval and one's a period, or
No, years is also a period. Maybe. Yeah, that's true. Yeah. Oh wait, Hadley. Oh yeah. Maybe.
right. So instead of today, you slept in there, and I don't know the syntax, but like February 28th.
Well, you can say you talked about this in the beginning, right? Hold on. You can say month, year, day, or whatever, right?
Yeah,
Year, month, day. YMD. So if we said YMD instead of today, you're saying.
and like try some weird
YMD 2018. Yeah. I need these. Oh wait, no.
is it just that
Yeah, 2018. 02.
you said this, but you said this,
So what was leap year was
multiples of 4 leap years. So,
well
yeah, so you
16.
can do 2016 or 229.
2016 02 29.
And then anything
Mhm.
place it.
Yeah. I mean, if we do 28 plus a year, it would have that extra day in it, right?
It's like, yeah, I don't even know. I'm also just thinking about the fact that February is short. If you do 29, it's still
There's no
Aha! Because, wait, 2016 02 29.
so 29 plus 1 year is
Ah.
Okay.
I don't know, that wasn't what I thought the problem was.
But we got it. That's good. So,
So I hope that's what he meant.
we're sure that, so if I did this by itself, that's cool, no problem.
If we do today, though,
Yeah, it's
It comes
plus
up
year
12.
1, I think, it's turning into.
Okay.
And then
Cool.
you could also just do that other plus year 1.
Yeah, exactly. Yeah, this part. Yeah. You have a question? Or you wanted me to try something?
no, so if you did today, though, it would come out as 12, the correct answer, right?
Yeah. It started off with this today and today, and it does come out with 12. Yeah. So it's not that why can't it work? It's when doesn't it work? And it would be when there is no corresponding day in the next year that you're adding. So it would only not work for February 29th, it seems. Yeah. Okay. I'm going to just note that.
Still the idea of dividing by period.
Yeah.
I mean months because they're variable.
Yeah. But I guess, quarter. No, I guess not. Yeah, it does. Yeah, I mean, but months is,
Oh, so it's doing it in the intuitive.
intuitive way, right?
period, we think of it.
Yeah. It's not D months because there is no such thing as D months. There's no fixed duration of month, but there is a human month, right? And so
No, but once you do an interval between two dates, it no longer is related to an actual real date.
well, I think the
You know what I'm saying?
interval, it's producing a period, no? Or was it producing an interval, Greg? Who was it that found that?
produces an interval.
Well, then you're right. I thought he said, hold on, where's the
Like,
part
an
that
interval
was,
is just like whatever, how many seconds are 265 days? How do you divide that by months? It's months is sort of
okay, hold on. Intervals.
They use this other operator to find out how
Oh,
many
intervals
periods
have
fall
a
into
starting and
the
an
interval.
ending point. Sorry, so intervals do know what day they started and what day they ended. So then you can count. You can say from May 2018 to May 20, 2019, how many months are there in between?
Human months are there in there. Yes.
But if you
Okay.
just had a duration, then you'd be up.
Yeah.
I think weekday is the only problem.
I agree. Okay. Yeah, this was an interesting one with the time zones. I think it's probably because I'm running in Azure. Actually, I could find that out. Dang it. Hold on 1 second. I may have it here. There we go.
There's some R environment too.
So if I just said, I started this one here, and then I said, boom. Oh, that's right. That's why I switched, was because of that. Okay, hold on. And then I went Alt Enter, and I said, going back. Oh, that's what I was going to say. Had that one. Where is it? That was weird. Did I close the other one? What was the name? This is chapter 13, 14? 14? Oh, date and times. 13? 13, sorry.
Well, online it is.
Oh, that is
Yeah,
interesting.
I was curious how I wanted to look up how the exercises in a book correspond to what online.
I
Okay.
think there's at least one intro section that gets a number online.
Okay. Yeah, so that's what it is. It's because I'm running in the cloud. I was confused. When I ran locally, I get it. You know, I'm in Los Angeles. So it does talk about that, and I've seen that format, that IA in a format before, when selecting time zones in apps that are on the web. And even in Windows, I think, when you try and select your time zone, isn't that what? Come on. Why are you not? Thought I could click that and change, but I'm not correct. All right, hold on. Time zone. No, this one has the old school. But some of them have, I don't know, it looks like they're doing some sort of concatenation or grouping or something in this one. Yeah. Because what he was saying was that that IA in a time zone format, the country or area, I guess, continent, that's what it is, continent / city. I've seen that format before, although apparently Windows does not use it. And he was saying that it was because the cities change less often. And this, I find, again, not an R programmer, but in Moment is one of the most confusing aspects of being able to say, hey, this date is in this time zone versus, hey, take this date and make it this time zone, right? It's easy to get confused. It's hard to debug. And I know for one particular project, we were having that issue. And it took us like 2 hours to figure out what was going on and to solve it. Anyway, I've been bit by that many times. So I like the fact that it's clear in here where he says force and with time zone. Those are the two methods. Might need a little light. Too light?
That's okay.
See,
I can still
yeah.
see
Yeah.
the TV pretty good.
Okay. All right. Okay. So any questions on time zone, dates, times? Pretty straightforward. All right. So I think we can fly through these next ones until we get to where was it? No, loops I think are pretty easy until we get to model. So this part 3 program, everything that we have done up until now in the book had fallen under the category of either explore or wrangle. And now they're going back and covering some basics that, in my opinion, should have been covered along the way. But I didn't write the book, so and he starts talking about pipes, which I found. I mean, like this explanation of pipes was way better than the explanation of pipes that they gave us back in chapter, 2 or 3.
Could have just not used them until he explained them.
Yeah, or put this earlier. Yeah, I mean, it's only like a 4-page, introduction to pipes, and it would have fit perfectly fine in that other place. And I agree with him. Like, I find out of the various ways that he describes, either intermediate steps as a new object, overriding the original object many times, composing functions, or using pipes, I think that the pipes definitely reads better. And he talks about when not to use it, and when you can't use it is first what he talks about. So functions that use the current environment. I think of that as functions that mutate, right? Like the assign, or yeah, I guess that's the only one he mentions, huh? Get and load, right? So both of those are bringing a bunch of variables into the environment, right? Or changing a variable that currently exists in the environment. Both of those mutating functions don't work well. And then finally, the lazy evaluation. And I was actually surprised that try catch fell into the lazily evaluated function. I don't know. I think that's kind of weird, but regardless, I think that those two class of functions, it would make sense why they wouldn't work with pipes. But then he goes on to say, even if you do have a function that uses pipes, or that can use pipes, when you should not use pipes. And the first one, if you're longer than say 10 steps, I agree with that, breaking it up into two pieces which are a little bit more understandable. They say, humans can hold 7 things or whatever, and then their stack pops. So, 10 would blow the stack. You have multiple inputs or outputs. That makes sense too. The sort of multiplexing, demultiplexing, that might be really confusing when it gets to pipes. Actually, there are functional languages that have that, and they have, thinking of OCaml dialects where they have the pipe greater than, and basically you can say, if there's an error, then do this thing, and if there's a normal flow, then do this thing, and if there's a if it ends, then do this last thing or whatever. Right? So there are languages that have it, but apparently R doesn't. Okay, so now here's the real question of tonight. How do you pronounce this thing? Magrittr.
Well, it's named after the artist, Magritte, or however you pronounce it.
Yeah, the Magritte. Yeah, it'd be Magritte. Yeah, and I found this actually.
Well, I actually don't pronounce the R. I just at the end. I just I just use the artist's name.
Yeah. So he says here. Separate button. I'm looking.
Have a WAV file in there?
No. I was going to try and zoom in. I keep doing. To be pronounced with a sophisticated French accent. I did find that when I was looking for how to pronounce this thing. Yeah, but unfortunately, this is not a pronounceable word in French.
That's why I just don't pronounce the R.
But you need the EU or whatever.
And then most of the time, you don't even need to include it.
Yeah.
Because you're
just piping.
It requires like tidy.
Yeah, tidy bursts, right.
And then you've already got the.
Yep. And so he mentions just a couple of other operators, the T and the, what do you call this? It goes both ways. I mean, I like just think of it like it goes both ways. It takes this and flows it into that, but then it takes that and flows it into that. So it's like a input output operator or something. Yeah.
And then when it's done, it
pipes the output back in the thing that went in to begin with. Yeah. Input output operator. That's what I'm going to call it from now on.
With Hadley on this, I would not use that one and just actually say empty cars gets empty cars pipe.
Yeah.
Mm-hmm. That's a tiny little bit of redundancy.
Yeah.
Probably. It's a big change, but in a very subtle.
Yeah.
Easily not notice it.
Yeah. Yeah. Okay. So cool pipes. We love them. Functions. And this stuff, I was bored to tears.
Yep. Nothing really to see here.
Yeah. I did but I found it interesting that in R, it's just the last thing that you execute that's returned.
Yeah.
Yeah. I mean, in most other languages, I mean, they have an explicit return. He mentions it somewhere in here, but in most languages, return is always, I want to return something, regardless of whether it's in the front of the function or at the end of the function. But in R, and I don't know if I like it or not.
I don't.
In some cases, if it's a small function, I kind of like it, so they don't have to type the return keyword. But then when it's like multiple statements and then that thing, and especially if the thing preceding it could be a continued expression. You know, like if I put a pipe on the end of the line, then that means that this next thing is part of that previous thing. And, you know, I think it can get really confusing. Am I returning this thing, or is it just being fed into one more thing, you know?
In my limited R, the last expression, I just slap the return around.
Yeah,
It
yeah.
just makes it really painfully obvious this is what this function is.
Yeah.
So do you use functions quite a bit in your?
Yeah, I had some long code, and so I wanted to break it up into easier to understand chunks. I'm not actually necessarily calling each function more than once, so it's not really code reuse.
Right.
It's just like here's an initialization function, right?
Okay,
Here's
okay,
a
okay,
whatever
okay,
function,
okay.
and there's a few that I do actually call like inside of the but the main reason was just for clarity. I always
I like
other
that.
languages,
Yeah,
just-
I like that practice, actually. It eliminates the situations where it can cause confusion.
And then for my main routine,
Mm-hmm.
the one that I'm calling to run the whole shebang, I use that, what is it called, invisible
Yeah,
at the end.
yeah.
I'm returning data in case I want to do something with it, but when I run it as a command line, then it fills up the
Yeah,
console and
right.
oh,
Invisible.
this is invisible.
Yeah. There's one other thing that I made a note of here in page 275, if you have the physical book, but it talks about another important use of comments. So I agreed with his beginning statement about comments, where he says, use comments to explain the why, not the what or the how. Totally agree with that. I've had many arguments over many days about that very topic. Agree completely. But the part where he says, another important use of comments is to break up your file into easily readable chunks. Why not just break up your file into multiple files? Like, why, if you're going to break up your file, why not just break up your file? And then you could name it, and you can tell what the chunks are, and you can prefix it with like, these are my, I don't know. I'm trying to come up with some cool names here, but you know, these are my string functions that deal with X, and these are my string functions that deal with Y, and these are my string functions that deal with Z, instead of having them all in one strings, you know, or whatever. You know, the breaking up into another unit gives you another naming opportunity. So I don't.
So I've been doing most of the stuff in their notebooks.
Yeah.
Can't really. I mean, I wouldn't know how you would break up that into multiple files.
Yeah,
Multiple notebooks.
So how would you refer to the other notebook?
Well, there you'd have to use a library or something, right? You'd have to have something that you can import from, you know.
But in our studio, can you have a project with multiple files?
Yeah.
And break things apart into files and reference them,
Yeah, you can sort.
source them.
And in Jupyter Notebooks is not so much of a big deal anyway, because you have the markdown that can, a single hash, gives you a nice big break, and then double hash gives you a sub break, and
I just wasn't sure how you would break it into files.
So that's the other benefit to doing functional programming. If you put everything inside functions, and when you source your files, then they get loaded into your environment as functions that you can call, but they're not actually doing anything until you call on them.
Yeah. So yeah, same
I
thing.
get it. I'm just stuck because, coming from other languages where you do create libraries and things like that, and from my usage of R so far, it's just been really to kind of understand the data and visualize something, and like I'm just kind of really running in a notebook, and I just don't kind of stuck. Like, what do I do? What am I gonna code this with? So.
Well, yeah, if you're doing that interactively, then I think
Yeah, I mean,
Notebook,
the notebook is like a giant REPL, read, evaluate,
Yeah.
print loop, right? So, if that's what you're doing is exploration, then the notebook is fine. But when you want to take that next step and just break it up a little bit more for maintenance, you've explored and you say, this is it. I just need to take these little bits of code from this cell and these little bits of code from this cell and this little bit of code, and then I want to make an actual executable that I can run over and over again. Like that's when you go to functions and breaking it up into multiple files.
Is this where you create your Shiny app or something like that?
You certainly could.
I don't know. I'm not that far in the book yet.
Kind of cool.
Yeah.
I don't think it's in the book.
It was mentioned. I don't know how much they go into it,
but
but
like I was running some different things with different parameters. Right? And originally, I just had a script. I wanted to, but when I changed the script, right? I changed the 0.2 to a 0.15, whatever, right? And then after I got it fairly polished, talking to the function, passing in the 0.2, all value.
All right.
Right? And so then I could just run it, but then I could run it and then I could pass in the optional.
So can I ask what you were working on?
So I was doing a Monte Carlo simulation.
Okay.
I had, a for loop that would just repeat this thing however many times. And so I was putting slightly different parameters. At first, it was just a script. So when I sourced the script, it would run the simulation. Right. Then I changed it so function, when I source the script, just has all the code in there, and then I have to run the simulation function all actually run it. So then the next thing I can do, which I'm about to do for an experiment, is when you get to the per r function. Right. Now I can create a list of all the different parameters that I want. And I can say run simulation and pass in all the different parameters, and it would take 48 hours to run all that. So that's how I switched from originally just having a bunch of statements in a script file,
right,
slapping it into a function.
And then what's your output? Are you trying to predict something, or?
Well, right now I'm still doing a bunch of visualizations, so I'm creating some plots.
Okay, all right.
So when I run this, I get, but I am actually saving off.
Use it.
Go back.
Go back.
And in fact, I can say, okay, take these two data frames that have one difference in their parameter, and I want to pair certain things.
Got it. Okay.
Cool. Okay, so that's. And the last thing he talks about is, environment. And this is what we sort of emphasized in the beginning. One of the big differences between R and other programming languages is the notion that everything is scoped to the environment, which kind of means that everything's a global. I'm just going to lay that out.
I don't think that's true.
It is.
If you create a function foo, and you declare I inside of that function, once that call is over, I is gone.
Yeah.
If you declare I inside of it, and hold on. So on page 288. Yes, that's true. So if you're saying if I'm using the, what is that called? The assignment operator, the less than dash, that is not visible outside of the function. That's probably true.
So in that sense, it appears to be
functional scoped.
Right?
Yeah.
But
yeah. So it's very similar to JavaScript, I think. It's functionally scoped within the function, but outside of a function, everything's global, right? Yeah.
And then I don't know if you noticed, but Yeah, or was it a later? Oh no, it's later in the modeling chapter. There's a data set called like Sim1 or whatever, and at some point he just assigns to Sim1. The Sim1 gets mutate. Da, 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 da. And at first I was like, wait a second. And then when I saw what actually happens, in that case, it's creating a local Sim1 global variable that takes precedence over the package Sim1 data frame.
Because he's inside a function when he's doing that?
No, just in general, if you have a data frame that's coming from a package, your local environment is first in your search list before you get to other packages, right? So like what was that thing called, NYC flights?
13.
If you called a local variable NYC flights 13, you'll get that. You won't get the one from the package. It's going to be earlier in your search.
Interesting.
But I was like, why did you do that? That's really confusing. You should have given it a different name.
Yeah.
And then he did it a couple times.
So it is my understanding that you can create, I think does he talk about it here? You can create a new environment. Like, and maybe as a package author, that's like a known thing that you should do. Such that when you're
hiding.
Yeah, you're basically saying, yeah, I don't want any of my globals exposed, only what I'm, sort of returning from the package. Right. So maybe that's what's going on in the case that you were talking about. We have there is a package. Why did that turn off? Yeah. Where it is though, so it has a package, an environment in that. Sorry, the variables in that package are scoped to an environment, so it will look at your environment before going to the imported environments. Maybe that's what's going on there. Anyway, but that's the environment is the only thing that gives you non-functional scoping in R, which is, it's more cumbersome to create an environment than it is to say this stuff is located within a namespace or a package that was from C# and Java, or a file, right? File scoping doesn't seem to be a thing in R.
Right. It does not seem
Yeah.
to be
Yeah.
a thing. And actually, every now and then, it like, you get this weird stuff where I'll forget to define something and I'll do it below it. But because once you run it once, it's in your global environment, then the next time you're like perfectly fine. And then you reopen the notebook and it errors and you're like, what? It worked the last time.
Yep. Yeah, I can see that. Anyway, so that's one of the reasons that I was talking about, maybe, I guess you have to be very careful when you're going to make a big project in R because of that, like that. If it's going to be a really big project where it's going to be maintained by a number of people, that's one place that would push you maybe outside of R, to another programming paradigm, language, platform, whatever. Yeah.
Or for performance, I guess.
Yeah, I mean, you can get performance in a number of other languages, but I'm just saying it would the fact that everything's kind of a global scope to an environment. I mean, that maintainability is not ideal if you have a huge project where that's the case. It's really difficult to know that you're stepping on someone else. Okay, vectors. So vectors, C++ vectors are really,
So, next
right.
time. Thank you.
Yeah. Bye. Vectors are really just, one-dimensional arrays of a specific type. That's really all they are. And and like C++, I think of them as like C++ vectors, you know, using the standard library, which is pretty much what they are. But one of the interesting things is they also have the concept of a list, which is a non-typed vector, like an array that can contain anything. You know, each individual cell can be any arbitrary thing, right?
And then the other thing is that operators are vectorized.
Yes, that is cool.
Every now and then, there's some operation I want to do that I think I can't do. And it's like, no, you really can't. Wow.
Yeah. Okay, subsetting, lists. So I was reading some stuff early on, back in like chapter 1, because in chapter 1, he just like throws you in the deep end, right? It's like, okay, let's start programming in R. ggplot, blah, blah, blah. I'm like, what the, you know. Yeah.
And it was my first book on art, and I still, you know, that it was my first book. Everything very elementary, all basic stuff.
Yeah, that's good. Anyway, so I was doing some research on R back in the beginning, and I was trying to say, okay, is it object oriented, you know, that sort of thing. And they were talking about, it's very similar to JavaScript in that it wasn't natively designed to be object oriented. But using lists, you can kind of create your own object orientedness. The fact that I can have a list of functions, right? Or I can have a list of variable fields and functions, like that is an object. So that's one of the ways that they implement object-oriented in R, is just using a list. There are other ways now that there's like a, sorry, this is a long time ago, like a version 3 and a version 4 and a version 5. Okay, yes, S4, S5.
Yeah, I was looking some of that stuff up. But,
yeah.
But also, I don't know all the, I forget all the correct programming language terminology, but they overload or whatever operators, and that's a way that they do object programming. So, like for example, ggplot overloads the plus. So is it overload or polymorphic or whatever? I don't remember the terminology.
Oh, but they get polymorphism through operator overloading. Yes. I get what you're saying. Yes, yes. But polymorphism, yeah, I get it. That makes sense. Polymorphism is just one of the things that's needed to be object-oriented, though. But yes, you're totally right. There are many forms of polymorphism. There's functional polymorphism and class polymorphism and all these different things. But yes, absolutely. That plus operator is pretty neat.
But even like as string is an object-oriented like method.
Not getting that one.
So basically, like as string will say.
Oh, I know what you're saying.
Like built-in R types, it'll know what to do.
Right, right.
If you give it a tibble, which is defined in the tidy package, how would R know what to do with it? Right?
But the R package itself defines as string overloaded as when tibble is passed in, right? Isn't that what happens?
No, the tidy package has to add a new method
right.
to
as string. Right, yeah. That's what I'm saying. So like there's a number of built-in as strings that take certain parameters. Right. And then the packages themselves have an as string which take their parameters to know how to do that. Yeah, that makes sense. Yeah. And that is a form of polymorphism. Exactly. Yeah. But the encapsulation piece is the part that I was talking about. That people to hide details about what an object can do except for its public facing stuff, you can use list encapsulation. right? List encapsulation of the object. You just create a list, which basically represents your object, and all the stuff, only the public stuff, only the stuff that are actually present in the list are exposed to the outside world, right? That makes sense? Yeah. Anyway, so that's like a way of mixing data and functions in an object to provide some sort of reusable encapsulation of that object. Anyway, I thought that was interesting.
By the way, last chapter functions, you didn't mention, but the ... thing.
Yeah.
I mean, have similar to that.
Yeah, I agree. That is, and actually, what's weird about that, on a language binge here, but in JavaScript, that's like you can pass any number of functions into any number of, like any number of arguments into any function, and JavaScript just inherently stores those as something that you can get at in the function, which is crazy.
But can they be named, or do you have to do more like argv2 or?
In JavaScript, you can get at those variables using, I think even dot. Can't you dot? Get at the passed in. I think you can just say args dot and then by name, or you can say args sub 2, 3, 4.
Yeah, you're just doing that. Although, or you could pass object literally to his name.
Are you sure you can't name those in by the args?
Not something I've done.
Yeah.
Yeah.
Okay.
But
I mean,
for
not something you should do, but I'm just saying I think it's possible. Anyway.
For the project that I was talking about, right, I have sort of an English that I call from the family, right? And I pass it a bunch of stuff that it has no idea what it is, and it just passes that into the function. So just the idea of like most functions, like ggplot, like has default values for sensible default values for all the parameters, so you can just sort of say like,
yeah,
give me a density plot and not specify any parameters, and it'll probably give you roughly what you want.
Yeah.
Like that's a nice paradigm.
Yeah, I agree. Yeah, the concept of named arguments and default arguments together is a hugely powerful thing in any language. Yeah, it really gives you a lot of flexibility and power. Okay, so let's see. For loops. So it was talking about sequence. So there's an output, a sequence, and a body are the primary components of a loop. So you have like a definition phase, and then the sequence, and then the body of the expression, which basically fills in the output.
That part's just
Yeah, exactly. Let's see. So they have the in construct, which is good and helpful and very similar to Python, as opposed to the explicit indexing, right? Okay, for loops versus functionals. Yeah, and then mapping, which that's a very functional construct, and that is hugely powerful. I think I put something on that in the very first meeting that we had, talking about how you do those link type things. Let me see if I can pull that up. I have it here. Oh, it's loading. Let's see. It talks about safely and error handling when you're chaining functions and stuff together.
Oh, can I make a comment?
Sure.
So I think I agree with Hadley that using map instead of an explicit for loop can actually shorten your code and make it a little easier to read and understand what you're trying to do. Then when he gets into like the shortcuts and he starts doing bizarro things with like dots and whatever other stuff, it's like, okay,
Now you've just
made your code really obscure and like, yes, you just won the contest of how to type the fused characters and make it, do what you want it to do. But this is not your principle of having your code be right. It's not going to run any faster. You've just like figured out this. I don't know.
Can you give me an example of the?
So was there an exercise or was it here where basically he like passes in function names in a list and calls the functions. It's like, I mean, it's good to know, and maybe once in a blue moon you actually need to be able to do this. But oh my god.
Oh, you can use a string. I see what you're saying.
Where was it?
So right here where they're.
Maybe it was the very end.
No, it's 327. I think you had it right. 327, where he's doing the tilde dot $r dot squared. Is that what you're talking about?
Well, that's actually okay. He's
Okay.
just pulling out a column. No, where was
So that's what I thought.
It's later on.
Mapping over multiple arguments, maybe in that section.
Yeah, it's after that. Invoking different functions, 334. I mean, yeah, it's like, I want to call, random uniform with these two parameters, and then call random normal with this parameter, and then I want to call random Poisson with this other parameter, and I want to do this by creating lists with the names of functions and lists with the parameters, and then
I see.
throwing this in this invoke map thing, which like this code is to me not readable.
Yeah, there are some ways to make it. Say that one more time. Yeah.
But I'm just saying that, like, I grew up on for loops, right? So
Uh-huh.
like, okay, yeah, I like some of. I can do the exact same thing as map with a loop, and in some cases it's easier with map. But I get where it's cleaner. But here it's just like, wow, you know what? Actually creating a for loop and looping through the different functions and calling them would probably be easier to understand.
In this instance, you might be right. Yeah, but there are ways of making this same code a little bit clearer in some other languages. I'm wondering if we could maybe
I
even.
get it, and I'm sure there have been times when I needed this. We're like, oh, I want to pass in the name of a function as a string and actually call it. And to be able to do that, it's a godsend. But since this is like the beginner R book,
Yeah.
it just seems to me that that's.
Yeah. Well, I'm having trouble understanding, like at the top of 35. What's he gonna do with that output data structure? Right? Like
Yeah.
he's got a list of these 3 different lists of results.
Oh yeah,
But-
right. It's not very.
But I mean, I would assume that then goes on to something else. But what?
What's going to take in
What's
that
gonna
thing?
take that thing? And
Yeah.
yeah.
Why
No,
is that the data structure?
in
that-
theory, they could have all been the same length. And
They were.
might have had an
They
easier
were.
time using.
I thought they were. The resulting output isn't that they're all 5.
Are they all 5?
Yeah.
Oh, okay.
Oh, they're just different. Oh, I see.
Yeah.
Right. So
It's
you
just
could
one's
theoretically-
you know, some are decimal and some are integer or whatever. But yeah, I hear you though. That's
It
not a
would've been
very
nice to see the application of it.
yeah.
He just showed how to do it, but not why.
Yeah.
Yeah. No, I mean, I get it. It's good that someone wrote this. I just don't know that this belongs in the beginner book.
No.
Because
No.
it's just, you could have accomplished the same thing with an explicit for loop.
Yeah, I agree. And then lastly, he covers predicates, which I think are just awesome, and I use them all the time in other languages because I don't program in R all the time. I would use it in R. I think, you know, the some and every and detect, those sorts of things, you know, I definitely, in other languages, I use those all the time. Like, what was the other one? All equal. Yeah. Does he mention that one?
I'm not sure.
I don't think he does.
What is all equal?
Like basically
Oh,
takes the first value and then makes sure that all of them are. Yeah.
Compare matrices, data frames, and it even tells you if they're not
So
equal. it
pairwise, everything has to.
Yeah, it even tells you what percentage.
So there's some in the counter and there's some in the fridge there. Either way,
I think you did mention that.
all equal. I didn't see that one, but maybe this is about the point where I was starting to like
I'm not sure.
read it for skim more than in depth.
He doesn't say stuff about
No, I mean, he's basically saying he likes math better than apply. I'm not saying you have to agree. I'm just saying that he pretty clearly says why. I use math and not apply.
How about you, Greg? Map or apply?
Apply,
Mm-hmm.
the native are built-in functions. Oh, so there's S apply, L apply.
well, there's a thing, you know, that in there you don't need to load anything.
Well, I'm just used to math, so it's kind of the core functional programming that math would use. So,
Yeah. Okay.
I found the learning curve for the apply function very easy. So
That's true, but when you used to them.
I'm just saying I found credible his point that math has a easier learning curve. Whether or not it actually can do as much or is as fast, I don't know.
Okay, so it's 8:15.
And it's kind of like
No. Oh, map is parallelizable?
in R.
Yeah, I don't know either. It's certainly parallelizable depending on what you're doing.
Okay. My understanding is that the intent is for it to be parallelized, whether or not the current version is.
Yeah.
Because for my simulation, I tend to use it for for loop, but there's a dependency carry state between iterations. So you can't parallelize. You have to actually run them all sequentially. And I was actually worried that if I used math at some point to parallelize it,
Yeah. Yeah. That's one of the things in C#. There's a for and then there's a parallel for, and that was one of the things that bit me when I was trying to optimize a particular method. Was exactly what you're just saying. Was the implicit state that I had that when I just flipped from for to parallel for, stuff started breaking in small, subtle ways that was not immediately obvious or easily debuggable.
Parallel for in R is very
convert it and transform vector or data set to something else, the whole cycle would be equal to an object.
So you're saying you don't get to choose how it breaks it up? It just
No.
breaks it up for you?
Oh,
Ah,
no, I'm saying that usually when you do for loop for an object,
uh-huh.
usually you create some kind of input,
Yeah.
you convert it. These four parallels in R, the whole T is created during the loop, and you should equal it to the loop. Yeah. Very-
Interesting.
Very strange concept. Do you know something like this in other languages?
Well, so, and that's what would be how math would work, right? You would say something equals the results of math. Is that what you're saying? Something equals the results of parallel 4?
Yeah, so it's like a function. It acts more like a function than a language construct, is what you're saying.
Yeah, and
Yeah.
I think it's because they don't want that hotspot. They want to be able to create the result in a distributed piecewise fashion and bring them all back together.
Yeah.
Yeah.
After it's done.
I guess.
Yeah, makes sense. So the last part tonight is the model, which I didn't get to. Let's do it next time. Okay.
I did. I'll say though, I did like this chapter.
Mm-hmm.
Um,
Okay, I meant that. Sorry, if you guys want to.
No.
no,
Because otherwise, next time might be light anyway.
yeah, I agree.
There's not much left in the book.
Yeah, I agree. This is the meat of the next time, although I think there will be a lot of discussion around Shiny and interactivity and HTML widgets and presentations and dashboards and so forth. The bulk of the meat is in this chapter right here. So I think, yeah, the two model chapters, exactly. So, what is very nice? Markdown. Oh, yeah. Yeah, me too. Use it a lot. Well, I use Markdown for three things, I would say. One is just Jupyter stuff, where I'm documenting. But when you create a page in GitHub, right, that's Markdown, right? So when you're publishing open source code, that uses Markdown. And the other place that I've used Markdown is when I'm allowing people to upload content, but I don't want to allow them to upload HTML for security reasons, because there's all these HTML injection attacks and that sort of stuff. So I allow them to upload Markdown instead of HTML, which is a nice simplified grammar and still gives them the customizability that they can bold and indent and have hierarchical order with what they're uploading, sending to me. That makes sense. Yeah. All right, cool. I'm glad that we agreed to postpone this because I was worried. I had some things come up today and I didn't get a chance to read it. So. All righty. We will see you next time. Ike should be back. And actually, I think next time might be the first time in a long time that both of us will be here. That's amazing. Yeah.
Any chat?
No. Good lordy.
I checked a little.
Where did I put it? Oh, here. Oh, that's where I had that thing. Let me stop.